So here are some audio ICs that I pulled out of salvage stuff. There's a pair of those are Japanese NEC PC2581Vs. Couldn't find a data sheet on that. No, didn't look that one up. I have an STK 350-230, and that I can find a data sheet on. And a couple of these. These are TDA 2009As, or 2009As, and a TDA 7269. I found data sheets on those. So, the data sheet for this guy, I was unable to decipher. But these guys, the TDAs, they both have good data sheets available. And this is the 2009A, and it's a dual 10-watt amplifier. And the TDA 7269 is a 14-watt amplifier. Pretty much the same part, but just with a different spec. And then there's also different support information that comes in the data sheets, like either some good application circuits and even a board layout for the application circuit. So they want to make it as easy for you to use as possible, so so that you'll use them. It's very nice. Okay, so we're going to start working on our schematic. Using KiCad to do the schematic capture as well as the board layout and whatnot. And so updating KiCad, updating the libraries. The libraries are separate from the application in KiCad, so you have to make sure that you update those. And then so now we can start on our schematic, and that's just dropping in all of the various components. We're copying a schematic, so it doesn't, basically it's just taking the initial notes into KiCad. And while we're doing that schematic, we're also doing things like picking footprints for various components that we're going to use and checking sizes for the various values and whatnot, and petting the cat. Okay, let's take a look at this switching circuit here. So this transistor is a switch, so it's either off or on. If it's off, then no current's flowing through here. This is going to be held high because it's being pulled up through this resistor to VSS. So this is going to be at whatever VSS is when this transistor is not conducting. So when is this transistor not conducting? When this switch is grounded. That means there's no power, there's no current flowing into the base of this transistor, so that means that it's off. But when the switch is in that position, this transistor is going to be biased upwards through this 10K resistor to VSS. So there's going to be some current flowing here, and we just have to make sure that this 10K resistor provides enough current flow to the base of this to make sure that this is in full saturation as it actually turned on. When it is turned on, that makes these resistors into a voltage divider. And that voltage divider is adjusting pin 5. Pin 5 is the mute standby pin. And so what we're trying to do is we're trying to find values of R and C such that this is steep enough for the C, and values of resistance so that we can get into the various ranges. So we need to be down 6 volts below VSS in order to be in play mode. So we need to have this pin drop below 6 volts if we're at 12 volt rail. So this has to be at 12 VSS minus 6 volts in order to be in play mode. If we want to be in mute mode, in mute mode, we need to hold this in mute is VSS minus 2.5 to VSS minus 6. So anything above this voltage is going to put this into mute mode, and if it's held high, it's either in standby or mute. It's in standby mode if this is held high. So, and standby is if this is held at VSS to VSS minus 2.5. Right. So if we keep it in the, here's VSS. If we keep it in the top range, this is standby. In this range is mute. And in this range is play. And this is minus 2.5, and this is minus 6 volts. So that's what we're trying to hit. So if we call this R2, this combination here, and this R1, V out is going to be R2 over R1 plus R2 times V in. So that's the voltage divider formula. And I want my V out to be approximately, well, 6 volts down from 12 is 6 volts. So to make that safe, let's try and get that into approximately 4 volts or below. So it's, we want V out to be around 4 volts or below. Okay, so here we're adding our new files for our PCB into our repo so that we can manage it through Git, and then we can start doing our PCB.